or I haven't been led. I have noticed a clue. Some of you, when I say shift tan, don't know what I mean. Even though, if I go back in my notes, and I go back in the videos, I talk about shift tan on your calculator could say second function. It could say second. It could say INV. It could say S. It could say shift. You have to know what it means. It's the button that makes your calculator do all the stuff that is written on the calculator instead of on the buttons. Because I do not purchase all your calculators, I do not know what button works on your machine. Some of you, if you're using your phone, it might even be a button that looks like that, like a shift key. I don't know. All the more reason why I said to go and buy a particular calculator. Calculate tan P, tan Q. There they both are. Calculate the angles, shift tan for both of them. Of course, you could have, it's like 0.99 and 1.1. Over here, it's like 0.5 and 1.8. Or, sorry, 0.4 and 1.8. Doesn't matter. And down here, please notice, I just wrote out what you had to do. This question is there for a reason. Because you notice the only thing that changed was the theta. But the math was the same every time. As us math teachers, this is something that we don't get. We give you guys a question. Do question 7, A, B, C, D. You do question 7A and you get it. Awesome. You do question 7B and you get it. Awesome. You do question 7C and you say, I don't know how to do C. You guys say this to us all the time. Say, well, how'd you do B? Oh, I did this. How'd you do A? I did this. How do you do C? I don't know. You see the fallacy there, right? That's like saying I walked 10 steps and I forgot what to do for the 11th step. Right? Math's the same all the way along. That's why textbooks give you questions like this, so you can start to see those patterns. And then same thing here. The only thing that changed was the opposite. The adjacent stayed 4 every time. 4, 4, 4. 8, 12, and 16 changed every time. Of course, if you found them as decimals, it was 2, 3, 4. Right? All right. Any questions about tan up to there when you were given the triangles? Not a real life situation, just the skills you need to do real life situations. Kind of like when you play a sport. Very rarely, if you play hockey, do you skate from blue line to blue line as fast as you can. But in practice, you skate blue line to blue line as fast as you can 1,000,000 times. Why? To work on your skating. When you play basketball, you do not shoot a 53 free throws in a game. But what do you do in practice? Stand on the foul line and shoot free throws. Right? I have played a bit of basketball. I know that free throws are part of practice. Why? I don't really know. You'll be lucky to take 1, maybe 2 a game. Ash, what? You take more than 2 free throws a game? You personally?
Yes, you take like 4 to 6.
Each player?
No.
Well then. And yet, every player practices. I'll use a rugby analogy. What's the first thing every rugby player does when they get a ball in their hand? No. Kicking. All of you start kicking. I don't know why. There are 3 positions on the field that should ever kick the ball. And yet the fattest prop, kick. I kicked it. And so I don't get it. But anyways. Now, questions that do have real life applications. What? No way. I'm not going to be a tightrope walker walking between 2 buildings. No, indeed you're not. But you may very well end up a stunt coordinator in Hollywood. No, I won't. How do you know? When my son was 4, I did not know he would have a part on a TV show. Yet now he does. When I was 4, I did not know I would be teaching math. Yet here I am. You know why? Because you can't see the future. If you could, you'd pick the 6 lottery numbers and we'd all get out of here rich people. But we can't see the future because it's the future. So what's the best thing to do? Be prepared for as many eventualities as possible. When I was 4, I have no idea. I was 4. I was concerned with eating cheese and not soiling myself. I don't know. I wanted to be a teacher from the 9th grade onwards. I didn't care what I taught. I just wanted to be a teacher. As I went through my schooling, my interests changed and my direction of study changed, but the goal of becoming a teacher never did. I lie. At the end of 2nd year, I wanted to become a psych major because I really loved psychology. And then they told me, you can't be a teacher if you have a psych degree. And I said, guess I'm not doing psych. Ironically, I have taught psych at this school many times.
Why can't you be a teacher if you have something?
Because according to a university, you must have majors in courses that are taught at high schools. It is not enough to have gone to university and know how to research and write and do all that stuff. Strangely enough, I know a woman whose 2 degrees were in Russian and stagecraft. She was able to become a teacher because there are a couple of schools in British Columbia that offer Russian as a course, and stagecraft leads to drama. But psychology, having a degree in how brains work, wasn't good enough to become a high school teacher. No, I just don't understand it. It shouldn't matter. If I decide to take basket weaving at a university and I wish to be a teacher, I shouldn't be stopped. But that is not my problem. I am not the teacher qualification services, nor am I the government, nor am I the universities. If I was any of those 3 things, there would be a vastly different experience for all of you coming down the pipe. But sadly, there isn't. There is the question. So, again, you can see that the only part of the triangle I need to do is this black part of the triangle right here, because I already know that that is 10 meters. So I took the part of the triangle that I care about, 12 and 21, and I did the same thing I'm always supposed to do with trig. Found my theta, found my adjacent, and did my math. Since I needed to get this done in 5 minutes, I didn't actually do theta equals 12. Adjacent equals 21. Opposite equals x. I didn't write that out because I only had 5 minutes to do this entire thing this morning during X block, which is why it is done very shortcuttedly. Now, somebody in the room is probably going to say, is it all right if I put 14.47? Of course it is, because 14.47 rounds to 14.5. Okay? Okay. Next question. Why is this guy standing on the top of the Calgary Tower and jumping off? Because that would be the only way to actually measure the Calgary Tower. To go up, stand on the very top of the antenna, and drop a tape measure, or yourself. You would never do that. So we use trig to find heights and distances that we cannot measure ourselves. Right? If you want to measure the distance across a raging river, you do not wade across the river, or it sweeps you away and you die. What you do is trigonometry. Same way those dudes outside looking at each other through the telescope across the road know how long the pipe that they've got to build in under that road is before they ever dig it up. They do not dig up the road, measure for the pipe, fix the road, get the pipe, dig up the road again, put the pipe in, then fix the road. That would be stupid. What they do is they do math first. Anyway, this question, that was the height of the tower, but you got to remember that the clinometer was 1.5 meters off the ground. So the tower, that's actually this triangle. That's the 189, and then you had to add in that 1.5. Most people just did that because they didn't read the whole question. And that's okay. That would still get you, in the new world of marking, 3 out of 4. Because you have all the trig. Sine. Now, we're done with tan. Everybody good with tan? What's the key to tan? What's the only side of the triangle tan will never use? Hypotenuse, ever. If you need the hypotenuse, you can never use tan. Okay? Unless you're using tan to find the 2 legs, then you're doing Pythagoras to find the hypotenuse. Now we move on to sine. There is sine. Same thing. Sine of A. There's A, opposite 8, adjacent 12, or 13. If you did that as a fraction, it will be somewhere around 0.65. Over here, it will be 0.33 repeating. Again, here you have to know what your calculator did. And I've actually made you do that in your notes, so it shouldn't have been too big a deal. Then you're going to do the same thing with cos. What's the difference with cos? You use the other side. You don't look across the triangle, you look beside you. And you will notice that the first 2 triangles I gave you didn't even offer you a chance to do sine. I only gave you adjacent. Yeah? Yeah. Now, this one I screwed up. I did sine A, cos A, and angle A, but I never did sine C, cos C, and angle C. Only because I was running out of time. If you're able to do them all with A, you're able to do them all with C. You just change the letters, right? If A is 7.7 over 8.7 sine, and cos is 4.1 over 8.7, then it reverses for C. C, it's 4.1 and 8.7, and 7.7 and 8.7 for sine and cos of C. But the third angle is always, that one's 62, so this one's going to be 28. That one's 54, so the other one's going to be 36. And that one is 60, so the other one's going to be 30. Yeah? Yeah, sure, you betcha. Who do I sound like? Oh, yeah, the guy who sells the... that guy's my favorite guy in that. Winter boots on sale. I love that guy. What were you... What? Pig from what?
The pig from Sing.
Oh, the pig from Sing. Yeah, yeah. Yeah, the pig from Sing. Yeah. Yeah. Sing's a great movie. I agree. It's also Swedish Chef from Muppets. Borgie. He's one of my favorites too. If you don't know who the Swedish Chef is, your loss. Bork. What? Who sounds like that in Toy Story? The Wiener Dog?
No, not that. It's just about the pet's life. The ripoff.
Oh, yeah. All right. 13, there you go right there. What's the only thing that changed? Theta is the only thing that changed. The operation doesn't change. Start recognizing when it works once, it always works. In this one, the only thing that changed was the adjacent, because the 21 was always the hypotenuse. 14. 14 was very tricky because you had to read the question carefully. A great many people in my other class did not read the question right. They did A perfectly. A is... everything that is up there in green. So, the guy wire for the jib sail. Wait a minute, Mr. Myers. I don't know what guy wires are. I don't know what jibs are. What? Of course I don't. I don't sail. What do you do in that case? You could have looked it up, or you could have asked Mr. Gill. Because Mr. Gill, even if he doesn't sail, would read the question and say, oh, okay, I can figure that out. Especially because this jib sail was labeled. So here is the jib sail right there. What's the mast? It's the big pole that goes up the middle of a ship. If you didn't know that, you could have asked. The guy wire is attached to the mast at point A. So something's attached at point A. There's two things attached at point A. One of them deals with the jib. So that. And the foot of the guy wire is 1.1 meters from the foot of the mast. Where's the foot of anything? At the bottom. So there is your triangle. This is 1.1. And the guy wire is 3.7 meters. So there is your triangle. I want the angle of inclination of the wire. There's only one angle of inclination there, the one that goes from flat to up. Right there. Angle C. Since I wanted the angle, it's a shift cos situation. Shift cos A over H, 1.1 divided by 3.7, you got 73. Now, a lot of people in the other class then read this next question and started to work on this triangle. Is that right? No, of course not, because this triangle, this question still says we are using B and C and angle C. It was a little test to see if you were paying attention to labeling. So we are still using this triangle, but we have new numbers. B to C is B to C is 3.2, and where is the mast? The mast is 3.5. So I still need angle C, opposite over adjacent. That time it's tan, and you got 48. Now, if you went over here and you made this 3.2, you're still going to get 48 because you're still doing opposite over adjacent. But I did it on purpose to see how many people would continue to use the same triangle, because that's what you were supposed to do. But if you did it over here, you're going to get the same answer, because still opposite is 3.5 and adjacent is still 3.2. Yeah? Yeah. And finally, the kite string. There's the kite string. Now, let me ask you this. Is this drawing a model of a person flying a kite? No. Why? Because the kite is attached to the ground. So does this measurement give me the actual height of the kite? Yes, because it's attached to the ground. What if I said I was flying the kite? Is that measurement the actual height?
No.
Why? Because I would be holding the kite, unless I was lying on my belly, holding it on the ground, which would be a stupid way to fly a kite. That would be no fun. Unless you rolled over on your back and held it here and then watched the kite fly. My kite is flying. I have a funny kite story. When I was in grade 11, summer between grade 11 and grade 12, I had a girlfriend. She was a lovely girl. We're still friends now.
Is it the same one from the math teacher?
No, this is a different one from the math teacher. She worked a lot. She had a job that required her to work a lot. She had 2 days off a week. I did not work as much because I didn't care. So, on one of her days off, we went to the beach. She wanted to fly a kite. She said she'd never flown a kite successfully. I said, I can fly the crap out of a kite. Give me that kite. So we start flying the kite. It's not very windy, so I'm running with the kite down the beach. Run, 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 run. Kite is in the air. I would like to see the kite flying, so I turn around and I start running backwards. At which point, I step on a half-submerged log on the beach, take a giant chunk out of my foot. It starts bleeding profusely, and I fall over. To which my caring girlfriend responds, "You've ruined my day off." And I said, "I'm awfully sorry about that, but perhaps we could see to my profusely bleeding foot." And she said, "Whatever, fix it." A couple of days later, I'm walking along, and my foot hurts a lot. And my girlfriend, who cares so much about me, says, "Why are you limping?" "My foot still hurts, dear." Well, I want to talk about that. You ruined my day off." "Whatever, my foot just hurts." Said, "Whatever, your foot's fine." And I sat down. She starts poking at my foot. I'm like, "Ow, that hurts." She pokes at my foot. "Ow, that hurts." She says, "Why are you being a wuss?" And she said, "Give me that." And she took my foot and she pushed it really hard, and a piece of wood that long came flying out of my foot. It was stuck inside there for like 3 days. But I was being a wuss. She still didn't apologize or, say I was hurt. I should have dumped her. I didn't. We stayed together for another year. No. I still did the dumping.
Oh yes, yeah, Thursday.
That was the girlfriend I had when I'm not happy in my high school picture over there. Grade 10, single Mr. Myers. Happy-go-lucky, ready to face the world. Grade 12.
I explained so much. It sounds like a bunch of words I can't say.
No, she was a lovely girl. We're still best friends. My wife was the maid of honor at her wedding. I know, it's weird.
That is weird.
It's kind of like a movie.
Yeah.
All right,
Wait, Mr. Myers,
Mr. Letty.
it's Dad Joke Thursday.
It is Dad Joke Thursday. And we are at an appropriate break in the classroom time because we have just finished something and we'll be moving on to something else. It's almost like you read my mind.
Wow, I'm pretty sure you forget.
I would. You're not going to do that today because today is a short day. When the bell rings.
Somebody's slow. When does it cost them?
So,
117.
what is different from the previous page of work I gave you yesterday and this particular question which you are looking at now? Eric.
You took away the triangle.
I took away the triangle. What a meanie.
I didn't get Scooby and the gang to come crazy.
But since you know you need a triangle, what would be a good thing to do? Draw a triangle. Now, let's make that triangle useful to us. The triangle is to represent our man Ike standing on a soccer field looking at the roof of a school. Where must the soccer field be? I don't know about you, but my soccer fields, when I am drawing them, live on the ground. It is awfully difficult to play soccer vertically.
Why don't you go on top of the school?
So, well then, he could not look at the roof with an angle of elevation, could he? No, dude. You cannot look at the top at a roof with an angle of elevation if you are on the roof. That can't happen. But he's not. He's standing on a soccer field. And even if that were the case, Kingston, then still, this would be on a roof and this would have to be another building. So the triangle would still stand. The soccer field has to be horizontal. Where is Ike? On the ground. Where is the school? It's the wall. What angle does the wall make with the ground? 90. How far away is Ike from the school? 42 meters. When Ike looks up, how many degrees does he go? Up 30 degrees. Now, do I have a theta?
Yes.
What is it? 30. Do I have a side of the triangle? Yes, I do. What side is it? It is the adjacent because it is beside theta and not the hypotenuse. And what side do I need? Why the opposite? There are two other sides. Why did you choose opposite?
Because that's where the school is.
Because that's where the height of the school is. And then I do my trig. Is it possible to do it wrong if you write out all three? It's really difficult because your data booklet tells you that the thing that uses opposite and adjacent is tan equals x over 42. And then you remember from your grade 8 algebra that when the number is on the bottom of a fraction, you multiply. 42 tan 30 equals x. And x equals whatever it equals. I believe it's 24 and a half. Great. Yeah? Yeah. Let's look at the next question. Abby is flying in an airplane at 2,500 feet. Where are airplanes?
In the sky.
In the sky. So Abby is up in the sky. The sky being up here on her plane.
If it's distance or altitude.
It's blue sky. It's sunny out. Why have you got to be that way? I know that. I know that is what you mean. Now, this is a prime example of when you lawyer ball yourself out of how to do work. The questions are not written to fool you. The questions are written so you can do trig. Take the easiest possible interpretation of a question, because that's what I mean. Abby is flying in an airplane at 2,500 feet. When you fly, you are up in the air. How far up in the air? 2,500 feet. Now I need a triangle, don't I? Yes? All right. Abby looks out the window and sees Mission, the town of Mission. Where is the town of Mission? It is on the ground. And she sees it at an angle of depression. So here is Abby's eyes looking down from the plane. Do I have an angle of depression right now? The way I have drawn it. Do I? Do I have an angle of depression the way that I have drawn it? Where do angles of depression live? Between the horizontal and downwards, yes? Do I have... Wait a minute. Those aren't the right answers. What are we doing right now? I'm all over the place. Do I have that? No. So I must make it. If Abby continues to fly this way, now do I have an angle of depression? Where is it? 15. If this son of a motherless goat. If this
The beautiful sky.
if this is 2,500 over here on the left, then what is this? On the right. 2,500. Now, I want to know horizontally how far away she is. Now, some of the more astute members of the class will say, Mr. Myers, did I need to draw that second triangle? No, you didn't. Because you, of course, know that if it's 15 down to there, what must it be up? Also 15. So you could have used the original triangle. Either way, you're going to get it. Where you're going to make your mistake is half of you, even though we've done this question, are going to tell me that this is an angle of depression. Even though we've gone over it to death. I guarantee you, when I mark your tests, some of you, hopefully not half, because I'm making such a big deal out of it now, will tell me that that is an angle of depression, and that is wrong. So now, we have everything we need, don't we? Do we have a theta? Indeed, what is it? 15. Once we have theta set up, now we name our opposites and our adjacents. What's the side we never have to name? Why, Ayla? Because it, yeah. Oh, Why? Because I am too. I asked why we never need to name the hypotenuse. Because it doesn't change. Thank you. I'm still unsure of exactly the word that came out of Ash's mouth. It sounded like stad. And I don't know what that is. Okay. We never name the hypotenuse because it never changes. No matter where I go in the triangle, the hypotenuse always stays the same. But the legs change. So once I have my theta set up, what is that 2,500? If I use the black triangle, it's opposite. What if I use the red triangle? Oh my good gravy, it's still opposite. And the adjacent, that's the number I care about. What uses O and A? Tan 15 is 2,500 over x. How do you find x? Divide 2,500 divided by tan 15. Yeah? Yeah. That is hard to punch in on a backwards calculator. Whose responsibility is it to learn it? Yours. How do you do it? 2,000 divided by 15 tan equals. And you get a number of something like 9,300 and something. Yeah? Borgy, borgy, borgy. Yip, yip, yip. No. Because the Muppets is not designed for children. It's got puppets in it, so everybody thinks it was for kids, but it wasn't. On one episode of the Muppets, Alice Cooper was on the episode. If you do not know who Alice Cooper is, he was a rock star from the 70s. And he was always looked at as a very evil man, even though all Alice Cooper ever did was golf. But on that episode, Alice Cooper spent the entire episode trying to buy Kermit's soul. That is not something that 5-year-olds should be watching. And yet everybody showed Muppets to their children. No.
I love the Muppets is my favorite.
Number 11. Everybody draws the triangle wrong. I would like to see if this is the one class that figures it out. Read the questions. Try to draw the triangles. I hope a great many of you started with a triangle.
No, I started with a square.
It would not surprise me.
I got it right. I got it right. I drew a triangle.
Okay. Now what? How far does the triangle rise? 1. Where's the rise? Is it the vertical, the horizontal, or the diagonal? It is the vertical. Excellent. Everybody who put a 1 there got it right. Where does the 19 go?
The bottom one. The hypotenuse. No, what?
No, because the car's the hypotenuse.
Adjacent. No, because it's rising. So the road wouldn't be flat.
This is what I mean. Everybody is in so highfalutin a rush to draw the triangle that they don't stop and think. I'm going to help you here.
Please. Nice car. Vroom, vroom.
There is my car, yes?
Yeah.
The car must drive along the road, yes? Where will the car drive?
The hypotenuse.
Up the road. Which means, where does the 19 go? On the hypotenuse. Because it says you are measuring along the road. If you were to build a road up the side of a mountain, you would need to measure up the side of the mountain. You would not drill a hole through the bottom of the mountain to the middle, drive in a tunnel, and then install an elevator to take you to the top. Although that is what my favorite amusement park ride in the world is. It is Atlantis' adventure at SeaWorld in San Diego. You drive around in a little roller coaster thing into a tower, and then indeed you go up an elevator. And then you go through the whole roller coaster instead of going up a hill. But then at the bottom of the roller coaster, Justin, it's like a log ride, and you get splashy splashy. It's a log ride and a roller coaster mixed together.
Where was this?
San Diego, SeaWorld. Now, have we answered the question yet? No. The question requires a triangle that has the road as being how long? 300. And I want to know how far I travel horizontally. So I need this number right here. How will I solve that? There are, the way I can think of it right now, 5 different ways to do that. Go. Find one. Tell me what x is. Go. You have all your triangular tools available to you. This might help.
Oh, I see.
What is going to be the same in both triangles? Well, since one of the triangles disappeared. What is the angle? No, the angle exists. You can see it. It's drawn right there. How will you find it? You don't need the angle, but you could use the angle. You could also use Pythagoras in similar triangles. You can do this entire question with Pythagoras, or you can do it with Trig. Wait a moment. Alrighty. If you knew this angle, could you tell me what x is? How? If you knew this angle in the big triangle, how would you find x? Sine? You'd use cos. But you don't know that angle, do you? But you can find it. How? By using this triangle, because that's theta, isn't it? They're the same angle, yes? So what would find me that theta? What's that? What's that? So what uses O and H? Sine. But I need an angle, so what do I have to do with sine? Shift sine. So shift sine. Oh, look at that. And once that gives you theta, once you have theta, that answer, shift sine of 1 over 19, becomes theta, doesn't it? So down here, you know that theta equals shift sine of 1/19. And you know that your hypotenuse is 300, and you know that your adjacent is x. What uses A and H? Cos. So I need the cos of that theta will equal A x over 300. What do I do with the number on the bottom? 300 cos theta. Now I know cos theta is shift sine 1/19th, right? So if I do 300 times shift sine 1 over 19, am I going to get the answer? Yep. And what is it? A great many of you will have trouble doing this all in one step. So what do you do first? You find theta and you get an angle. Then you take that and you plug it in there. So what you should have gotten is 299. And that makes sense, doesn't it? Because the angle is very small, isn't it? It's like 3 degrees. 3 degrees is like that much.
You probably want to show more decimals because otherwise you'd have to round it up to 300.
Thank you. That's where I was going next. A great many of you will notice that on your calculator showing you 299.5 something, isn't it? Which you want to round up to 300, right? But you can't say 300 there because in reality, this must be shorter than this, yes? So you have to include your decimals. This is a spot where you cannot round, or you will end up with an answer that makes no sense. Agreed? All right. Now, we're going to do something a little different with number 12. I want to point you guys in kind of a more advanced direction. What I'm about to do is not necessary, but it will help you be better with trig. Everybody understand what I'm saying? Watch what we do here. Put down your calculators. Better yet, turn them over so you're not even tempted to touch them. We are only going to do trig. I want the area of this rectangle. How do you find the area of a rectangle? Base times height or length times width, yes? Everyone agrees? Okay. So if we were to name one of these sides L and one W, which side would you name L? The vertical? You'd make that L? Cool. Which makes this W, yeah? Everybody okay with that? All right. Now, that gives us this triangle, yes? Everyone agree? What do I know about that triangle? I know a theta is what? 21. And what else do I know? Hypotenuse is 12.7. Now I need an L, don't I? What is that L? Opposite is L. And what is that W? Adjacent is W. I know I have an H and I need an O and an A. What will get me the O? Sine, cos, or tan? Sine. What will get me the A? Cos. Okay. Go for Myers. Yes. No problem. Car with a K. You're needed downstairs. Office. Okay. So what would find us the O? It was sine, correct? So we are not going to touch our calculator. Sine 21 equals L over 12.7. We're still not going to touch our calculator. What would I do here? Times 12.7 sine 21. Agreed? Everybody cool? Okay. Now, we said that cos 21 would be W over 12.7, yes? What would I do there? 12.7 cos 21, yes? That's L. That's W. How do you find area? Multiply L times W. Yeah. There's L, there's W. So what do I punch into my calculator? If I bracket, 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 I can get it all in one step. And what does that allow me to do? Round it off properly. Because if you do this, you're going to round there, aren't you? Don't lie to me, you're going to. And if you do this, you're going to round there, aren't you? Then you're going to round around, then you're going to multiply a rounded number times a rounded number, then you're going to round that number, aren't you? Are we in the interest of exactitude? We would like to be. Now, do you have to do it this way? Of course not. But as you go further, it is going to be more and more important to have the right answer, not just an answer. Especially if you are choosing to go into anything mechanical or anything engineering or any kind of physics. You actually need to be able to think this way first, because every time you round, you're going to be a little bit off. And if you have to do a problem that requires 10 roundings, then every single one of them is going to be slightly erroneous, isn't it? And every time you round again, you're going to get further and further away from what you need. Picking up what I'm putting down? This gets me the best possible answer. Does everybody understand what I did there? I didn't touch my calculator until I had to touch my calculator. And if you show your work, it's not that hard to do. Is everybody cool? All right. Let's see if we can put that together right here. The question says I need to find m to n, yes? Everyone agree? Which means I must be working with this yellow triangle. Everyone agree? Can I, right now, work with the yellow triangle? Why? I don't have enough information. I need two sides or an angle and a side. I do not have that, do I? However, what do I notice about this blue triangle? I do have two pieces of information, and I can pick up this third side, yes? This third side of the blue triangle, even though it is a leg in the blue triangle, what is it on the yellow triangle? It's a hypotenuse. So if I can find that blue leg, do I also know the yellow hypotenuse? Yes, let's do that. We're going to work in blue. What's my blue theta? 33. What else do I know about blue triangle? The hypotenuse is 8.2. What do I need? There's two other sides, one of which will not help me. One is what I need. I need the adjacent, and I'm going to call that x. Everybody cool? Okay, so what uses a and h? Excellent. Cos 33 equals a x over 8.2. Math-wise, 8.2 times cos 33. Should I go to my calculator now? Can I go to my calculator now? Yes. If I want the best possible answer, should I? No. Which one does Mr. Myers want? Or does he care? What direction are we heading with marking? We've talked about this. The 1, 2, 3, 4 scale, right? If you go ahead and punch this in now and round it off, are you at the 3 or the 4?
3.
The 3. If you leave it as 8.2 cos 33 and use it later, where are you? The 4 scale. Does everybody understand? All right, so we know that x is that, correct? Now, I'm going to change over. I'm going to get out yellow. In the yellow triangle, do I have a theta? What is it? 49. What else do I know in the yellow triangle? I know the hypotenuse is what? 8.2 cos 33. And what do I need? No. What do I need? I need m to n. Can I make this x? Why am I not allowed to make this x? Because I've already got an x, so I have to choose a different letter. What is y? Adjacent. Opposite. Now, what uses O and H? Sine 49 is O, y over h. 8.2 cos 33. the numbers on the bottom. So what do? Multiply 8.2 cos 33 times sine 49. And I can get it all in one shot. Do I even need brackets? Look closely. Think of bed mass. Do I need brackets? What math is happening right there? Times. What math is happening right there? Multiplication. Do I need brackets if it's all the same operation? 5 times 2 times 2. 20. 5 times 2, 10. Times 2, 20. 5 times 2 times 2. 5 times 4, 20. All the same thing. Your job tonight is 14 through 20. Do your best. You will have trouble. I know this. Do not be feared.